periods. Because this is review and I noticed, how do we feel about this first off? Our quadratics, we still feel like black belts? We're still good? Okay, so I'm going to go a little quicker through this. If you didn't get these three things, you know what to study. You will probably need to have some of this memorized. Standard form, let's do together. F of x is equal to, or y is equal to, a
squared plus bx plus c.
All right. Vertex.
Y equals a times x minus h squared plus a.
Good. Good. Factored. F of x equals?
A times x minus b times x minus q.
All right. Those are our three. Those are our three. Good job. So we have those three items, components. What can we find from our shopping list here? What can we find for standard form? What's the easiest one to find? For all of them. We can always find what for all of them?
Open up or down.
Open up or down. A positive, negative. A is positive or negative, happy face or sad. A is positive, negative, happy face or sad. All right. So we have that for all three of them, and they'll always match. If you convert between them, it doesn't change the direction of the graph. It's always going to be up for all three if you convert between. What's the other really easy thing to find in standard form? Good, good. So we have the y-intercept, and it's equal to what value? C. Because if you plug in 0 for x, you're going to be on the y-intercept, and all the only thing left over is that constant. If it's missing, if you have, you end up with this, y is equal to x squared plus 2x. There's no c. Actually, there's a c, and what's the value for c? 0. Okay, so just so you know, if there's missing terms, if it ends up x squared plus 8, what is our b value? 0, because that bx, the b must be 0 in order for it to cancel out that term. Keep that in mind. Nothing's ever missing. There's just a 0 involved. Okay, what else can we do for standard? What else can we find?
Axis of symmetry.
Good. Axis of symmetry. X is equal to?
Negative b over 2a.
Oh, it's like you know this. Makes me so happy. All right. Vertex. We know that the axis is on the vertex. Good. And then you just plug in to find your y value. Your x is going to be from the axis of symmetry. Your y is going to be after you plug in. You find what the y value is corresponding. That's all we can find with those. Okay. Vertex form. What can we find with the vertex form?
The vertex.
Actually, I was trying to get you to say axis of symmetry.
Oh.
That joke. All right, what's the axis of symmetry? X is equal to? H. So then we can find the vertex. It's at H. Okay. That's good for that one. Okay. Factored form, pretty straightforward. Happy face up or down. What else? Roots. And I want you to write this. Roots are going to be P and Q when y is equal to 0. And I want you to tell your neighbor, why do we find our roots? Our x-intercepts. When y is equal to 0. Tell your neighbor real quick, 5 seconds. That's never happened in 10 years of teaching. Wow. Crazy. All right, here we go. Why is it? Somebody really, for a tropical vacation, tell me why this is so? Adnan.
Alright, so I know that in the fourth one, it would be y. Y equals a times x minus b times x minus q. So I know that you have to find 0 in order to find the root, because that's where they intersect. So, for example, if you have roots of 3 and 1, you would need to find a number that would isolate the 3 and the 1. So then it would be the opposite of those numbers would be -3 and -1.
Okay, you went pretty far with it, and I just want it. Good job. I want to clarify so it gets the narrow view of the answer I wanted for this one. So the only thing to think about is when y is 3, it's up here at 3, right? It's a line. When y is 2, here. When y is 1, here. When y is 0, we're on the x-axis. When y is 0, we're on the x-axis. Okay? So when y is equal to 0, I can find my roots. I can find the roots when y is equal to 0 because I'm on the x-axis. That's where the function will intersect. Okay.
Okay, let's try one then.
All right, we have this f of x is equal to the quantity x minus 4 squared minus 4. We're going to graph this all the way out. First off, what form are we in?
Vertex.
Vertex. So that gives you a hint. Find your a, positive, negative. Find your axis of symmetry. Find your vertex. Start putting that information in the graph. We're going to go through this quickly. So, like, I'll give you a minute or two for each little part. Okay, let's do it. All right. Literally, maybe a minute. Just to get 3 parts here. We're finding a, find axis, find the vertex. Alright, once you're done, check with your neighbor. See if they're done. If they're not done, say,
It's taking you so long. Just kidding.
You say just kidding too? It's perfect. It's perfect.
I told her to say it's not her fault.
Oh, it's the inside joke. All right, so let's look. Oh yeah, double check your neighbor. We're about to bring it back in like 5 seconds. Double check. That tells you if you need to focus on one part when I go over it. Maybe you didn't know it.
So you can tell. It definitely is that.
Let's try this. All right, is A positive or negative? Positively, a happy face with the minimum here. Okay. The A value is up in front here, and there's nothing here, so it's a positive 1 that's here. If it was negative 1, there'd be a negative out there. That's all we're looking for. Okay. Now, the axis of symmetry, it's equal to H. So you have to think about what value for H would you plug in here to end up with it looking like that? What would you put in here? Positive 4, right? It's the one where it's counterintuitive. If I put a negative 4 in here, it would end up being x plus 4. That's not what we had. So no, my H value is positive 4, which goes here too. Okay. So now, what is my K value? Negative 4. All right. I think we've done all we can with this grouping of information. We know that 1, 2, 3, 4. There is a axis of symmetry. X is equal to 4. The vertex is at 4 for x, and at 1, 2, 3, 4, negative 4 for y. So here's my vertex. This opens up, so this would be fine to put right here. All right. What's next? What should we do next?
We could put it into
Wait, what's that?
convert the equation to a standard form, then factored form, and find the x roots.
Perfect. Perfect. Let's convert this right here. Let's make it into, I'm just going to get rid of the stuff. Well, no, I won't get rid of the stuff. How about that? Let's just do it right here. So I'm going to give you the hint here that we aren't distributing this squared value. We are going to do, what's our favorite material for our hats? Bad joke.
Oh, foil.
Foil hat joke. I don't even know.
It was kind of a loose association.
It's bad. All right, you got it though. You got something. You got it. All right. We are just, I want to make sure you look at this expression squared as the expression times the expression. You can never distribute an exponent. It's saying the quantity is squared. Quantity is squared. So we use FOIL for it. First, x times x. X squared. Outer, x times negative 4. Inner, negative 4x. Last, positive. All right, so we got here x squared minus 8x plus 16. All right. So what else do we know from here then? Or Ethan, what was the one piece of information we'll grab from this? So look at our 5 things. We already have these 3. So it's either y-intercept or the roots. You weren't answering because you knew that I was wrong and it should have been negative. It should have been positive 12.
Yeah, I knew that.
Oh,
That's good,
wait,
Ethan.
but
Sometimes you gotta like wait for the teacher to see the mistake. All right, your y-intercept is at 12. The reason being is it's our c value. We know that the y-intercept is always our c value. That's really clever. Trick me. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We already know the shape of this then. We know it's going to come down to the vertex and up here. We just need to know one more thing. The roots. So we're going to take this. We're going to take this and we're going to use the x method to get it in factored form. X squared minus 8x plus 12. That'll work. So get that into factored form by doing our x method. You guys remember how to set up the x method? You want a little review?
Please.
Everything is alphabetical from top to bottom. Everything is alphabetical from top to bottom. Watch. Your b value goes here, your c goes here. Right? You're going to add with an a. Add starts with an a, right? Add. Then you're going to multiply, starts with an m. Add, multiply, b, c, alphabetical, top to bottom. Maybe that's something else. A little bit, right? Sometimes if something's like alphabetical, then it clicks in a different way. You're like, oh, it just makes sense in our language. So, all right, let's put the 12 here. Let's put the negative 8 here. That's just our b, that's our c. Now we have to look. We want those 2 numbers to multiply to give us 12. Add to give us negative 8. So let's see, what multiplies to give us 12? 6, 2, negative 6, negative 2, 4, 3, negative 4, negative 3, 12, 1, negative 12, negative 1. Any others? I'm not missing any, right? That's it. Which one of those? See, now you have all the multiples here. You can look at each one of them and say, well, which of them add to give us negative 8? No. Yep. Negative 7, negative 13. No. This one. Okay. So we're going to put negative 6, negative 2. That's what goes in there. All right. Now let's look to see what we talked about before where we had an extra starburst word. The x-intercept, or roots, p and q, are p and q when y is equal to 0. So now all we have to do is make this equal to 0 because that's going to tell us where our roots are. And what makes this first expression 0?
6.
When x is 6. Positive. Positive 6 there. It's 6 minus 6, 0. How about this one?
2.
2.
X equals 2. When we find these 2 values, we're doing the factoring process. We are not finding the roots of this process. The x method is not about the roots. The x method is to get us into 2 expressions like so, into factored form. From there, we can deduce when f of x is 0, when does this equal 0? Because if that's 0 times anything, we get 0, and vice versa. You may have a mistake I've made. Do you see it? No? Question?
Isn't it supposed to be f of x equals, like for the equation, x plus 6 and x plus 2?
Yeah, that's what I thought.
Because the factored equation is x minus, and then the factors in the x one were not like negative, so a
That's
negative and a negative is a positive.
Yes, those are
No, but it wouldn't make sense then, because then if you did the thing you did, if then you did the little equation to find 0, then you would get negative 6 and negative 2, which doesn't make sense.
That doesn't make sense with it.
Because you would have to go from the vertex and go all the way to negative 2.
I'm going to pause it. And that's good. That's how you would notice your mistake. If you did that all the way out, you would see it doesn't make the shape we're making. The key to this is the key. And this is just a little confusion because it's like this x method kind of happens right along with finding the roots, right? But the x method is a factoring method. We are not finding the roots when we're doing the x method to factor. from a trinomial to two binomials. This negative 6 stays as a negative and jumps right over here. This negative 2 stays and goes over here. And if you're not sure and you don't believe me, then watch. X minus 6, x minus 2. Let's FOIL it back. We better get where we started. First, outer, inner, last. X squared minus 8x plus 12. Is that where we started? Yeah. So you can always double check yourself with factoring, distributing. You can check yourself.
So it'd be like the negative 6 and negative 2, like they aren't P and Q, so that's why when you put it in,
Yes.
it wouldn't be the net. Because they're not P and Q, so you wouldn't put them in the equation as minus, negative.
Then why is the equation wrong?
Because look at this.
That's when it is P.
The
That's when it's on
equations,
actual
the equations are our go-to. The equations never change. The way that this in factor form works is it's x minus p, x minus q. So I actually would prefer you to think about whatever you factor goes into this. But if I'm looking for what my, well, even think of it this way, because this is essentially x minus p, x minus q. So in this situation, you could see that those are my p and q values, but that can get a little bit convoluted. So I don't want to teach go in that direction. Rather it be X method, you take the values that are factored and they go right in the expressions. I don't want you to try to connect these things to what P and Q are. Even though it may seem easy for you right now, that's a different way that I've taught it. And if you understand it that way, that's great. Don't try to change your view right now. Okay. This is factoring, those numbers stay. You make them equal to 0 and you solve for when they're equal to 0 and we get our P and Q.
So on the equation, if b was positive 8 and the factoring would be positive 6 and positive 2,
So it'd
the
be,
equation would be x minus or x plus?
then it would be x plus 6, x plus 2, because you take whatever those values are, you put them right in there. We're not substituting. These are not the roots, so we don't substitute. I'm not putting negative 6 in for p and making this x minus a negative 6. This is not p and this is not q. These are factoring from the trinomial into two binomials. In that step, we say, well, let's make it equal to 0. You can even do this step. X minus 6 is equal to 0. X minus 2 is equal to 0. You solve and you get our P and Q right there. So is everyone okay with how to do the X method? We're good with just doing it? Like if I just said, here's some numbers, do the X method? Is that okay?
Example with X.
Okay.
Give another example with X.
So I feel like people are trying to just say and argue that no, these are the P and Q. I must be wrong, or like there's something, these are not the P and Q. That's the answer to that. That was a misconception. These values are for factoring to get us to the two binomials. The P and Q happen in this next step. We figure out what P and Q are in the next step. Okay? So if you're not sure why this isn't P and Q, the answer is because they are not P and Q. It would be something that we labeled and attributed to these values, and there's no reason to attribute that as our P and Q. These are not roots. These are within the factoring process. Hope that's a little clear. That's about all I can spend on that one. Yeah? You may. Yeah?
So the two numbers that come from the X method are the two numbers that you should see right after the X
Correct.
in the equation. Like there's negative 6,
It was minus
you see
6.
negative 6 right after the X.
It was minus 2.
And that's all you need to do.
That is the factoring process. That's just going from here to here. Here's where we find our roots.
If it was positive 6 in the X method, then you would only see a plus 6. And that's
This is correct. Hey, if you don't like it, this is the problem. This type of problem is the one to do, have the work done for the test. This would be the one. Okay, so that's a good thing to figure out, even if you figure out what you're not quite good with. Let's put this one here. 1, 2, 3, 4, 5, 6. There's the other. Done. Okay. So I heard a request just to go from. So that's enough for this problem. So let's try to go from. Let's just factor this. Let's go from. Let's see, f of x is equal to x squared. Let's go minus 3x plus 2. All right. So I'm setting this up. 2 and negative 3. My b and my c are here. What adds to give it? What multiplies to give it? So this could be a problem. This could be a problem totally separate from graphing, totally separate from roots. I could show you the X method doing this process if we aren't even talking about graphing quadratics. It's a method, a subpoint to get more information, and you could do it on its own. So we're going to just end up with 2 new quantities here. Okay, and what makes that? What makes positive 2? What multiplies to give us 2? 2 and 1, negative 2, negative 1. It's prime, so those are our 2 options. Now, which one of those combine to give me negative 3? Okay. So we have negative 2, we have negative 1, watch. X, negative 2, negative 1. Negative 2, negative 1. So this could be a problem. Honestly, like this could be later in the year in Math 1. I could have taught you this, right? And it could have just been, hey, factor from the trinomial down to two quantities like that. You'd use the X method. I wouldn't have to tell you anything about roots because you wouldn't learn that till this year. All right, yes.
So if it was like positive 3, right, and then it'd be 2 and then 1, then you're plugging it in, or not plugging it, but like, substituting it, I guess, in the X plus 2, or?
If we had this, if we had this instead, yeah, this is gonna work out to be x plus 2, x plus 1. Because the signs are different and everything is different what we're considering. This would be, we're trying to find 2, we're trying to add to give us 3. So that's going to be plus 2, plus 1. That's why those go there. The next step is to say, well, I'm going to make it equal to 0 and actually find my roots now. That's next step. Finding the roots is something totally different. This process right here, like I said, could be a question. I would have to teach no more. I wouldn't have to teach anything else for a Math 1 kid who is learning this. Okay. So just separate them, try to separate them. The X method is how you get to factored form. Then you have it in factored form to then work out the roots. All right. Okay. What have we done? We've done FOIL. We've done the X method. We haven't completed the square. So I'll give you one problem, complete the square, and then you know how to do all these different parts. Yeah? Okay, we got one more problem, guys. All right, let's do it. This good to go? All right, let's do complete the square. Let's do this. And I'm just going to ask you for this. For this, I want you to find the vertex, or axis of symmetry, and vertex. Okay, if you get lost, peek up here. That's how I set it up. And now we're ready to complete it. Essentially, this is the area that isn't filled up. We got to fill it up. Total space of 9. What should I put in here? What should I add? 12. So that means I need to do what? Here's our 2 identical expressions. And that is now in vertex form. So now the last thing I'll ask you to do is find what is my axis of symmetry, what is my vertex. So double check your neighbor that they're all caught up, see what they got. Yeah, I just want to make sure you got to complete the square example.
Oh yeah, I remember. Hold on for a second.
Wait, no, it's not that.
That's
No, for that.
Hello?
It's like,
like the x.
it's like,
X
oh,
plus
it's like
plus.
All right, guys, what is my axis of symmetry, please?
negative 3 x equals.
I like it. X equals -3. How? Why? Because remember, this is vertex form. This is the vertex form. It's x minus h. So if I put in -3 here, what happens? It's x minus -3. X plus 3. So I know that is correct with that. However you remember that. Make a note to it. You could say it's always the opposite. Or I'd say always comparing it to the original to kind of get an idea of what did I have to put in for my h value to make it look like this. I have to put in a -3 right here. Negative, negative makes it positive x plus 3. So then I know my vertex is 3 what? Right? Voila. Quick comment.
Oh yeah, I just wanted to comment about the completed square. So basically, what I did, by mistake I added 9 in the box because I thought because your total is 9, so I thought you would have to subtract 3 out of the 9. But then you said that you have to find the value of 9
To fill it.
Yeah.
Yeah. This is the total volume of this part of the overall square. I'm completing this square, so if I just have this part, this is all I got, essentially, right? That's not going to work. We got to have a complete square, so I look to see, okay, well, this side is 3, that side's 3, so the total is 9 in this area. So the -3, you're in deficiency. You got to hold. You got to get it 9 tall, so we got to add 12 to it and subtract 12. So that's a good way. That's a good bring up. That's a good bring up. Okay, guys. Thumbs up, sideways, down. Can we do it? Most of it? Can we do half of it? 3/4 of it? Putting the squares easy?
Yeah,